Hey guys, I know number 13 on the 9.2 and 9.3 homework can be very difficult. So I wanted to let you know I did do the problem all the way through and I just changed the original angle to 50 degrees. So if you want to like pause it and like look at my work here, you're more than welcome to. Colt and I were talking about something that happened in his that I didn't think was like allowable, but he ended up getting the right answer. And the long story short is because it was like sine of 60 or cosine of 60, since those have special properties, what he did appeared to work, but then it didn't. But I think we got everything all straightened out once we kind of looked at it together as 50. All right, so I'm going to erase it. I'm going to go back to what it was originally. So 60 degrees originally. So one of the main things we need to be able to do is figure out what its x and its y velocities are at the beginning when it's still one item. So the original velocity, I don't think that's going to be terrible for you. The original velocity in the y direction is going to be 20 meters per second, and it's going to be sine of 60 degrees. Let me grab my calculator. Yeah, it's freezing in here.
You know what? I'm freezing over there, and I'm like mine just went up to 66. Mine was at 65.4.
Yeah, it's super cold. Yeah.
Okay, I'll put my coat on. I'm cold.
So 20 sine, oopsie, not double sine. Oh dear, I'm just gonna start over. 20 sine of 60, and I'll get 1732. Now I'm gonna do 20 cosine of 60, and that's gonna be my x velocity for projectile motion. And these are meters per second. Bananas. Okay, and then we're going to figure out, one of the main ideas here is that we really need to know the time of the explosion. But what we can tell is that the explosion happens when it's at its maximum height. And when it's at its maximum height, it always holds true that the velocity in the y direction is 0. Remember how now the x direction is not, all of these numbers here are from when I changed it to 50. Let me get rid of stuff. Okay. Same equations will hold true though. Okay, so the y velocity at the tippy top is 0, and the x velocity at the tippy top, because that doesn't say anything about air resistance, yada yada yada, the x velocity is still 10. We learned that back in, I think chapter 4 when we did projectile motion. Okay, so those are the velocities at the tippy top. Just based off some old school things. Now I want to figure out how long it took to get there. So how long was it in the air before it exploded? The reason I want to do that is because then I can figure out how far it went horizontally. Because the ultimate goal is to figure out where this thing lands, this fragment, where that fragment lands horizontally. All right, so if I take this old school equation, Vy at this spot is 0. My original Vy was 1372. Or sorry, 1732. I had a moment. My acceleration is negative 9.8, and my time is unknown. So what I would like for you to do is to solve for this time. Remember, this is the time to get to the top, okay? Then what you're going to do is you're going to figure out, okay, now that I know how long it's been in the air, what is my x position? Here. Because that's halfway of your projectile motion before the explosion. So you're going to use this formula with your new time. And the reason I crossed this off is because the acceleration in the x direction is 0. So you're going to use this formula with your new time. Remember, your original x position was 0. Your original x velocity was 10. And your time is whatever you got right here. And then this whole thing zeroes out. So please solve for your x position here. Now remember, that x position that you get, that's just half of the horizontal distance. And what we're going to do is, back in the 9293 notes, there was a statement that was said that after an explosion, that the center of mass will continue in the regular projectile motion path. So if I were to do this, the center of mass would go like that. So the center of mass is made up of this guy and this guy's position. So we know that this one Let's see if I can change color. We know this one is just gonna land, boom, 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 right there. And this one is gonna go way over. So the center of mass of the system is gonna be the balance of that position and that position. So right here, which is just the original parabolic movement. So what we're gonna do now is, now that you have that X position, the X position of the center of mass is going to be double this position. So I'm going to write the X position of the center of mass is going to be double of that, because we know it finishes the parabola. So if that's in the middle of the parabola, then the center of mass is at the end of the parabola, which is double of that particular spot. Now remember, that's the center of mass. So get a number there for me. Double that. Then please take that number and put it in right here. So this is your center of mass equation. So let me zoom in right here. This doesn't change from one problem to another. This is your center of mass equation. So your center of mass is whatever you just got. Remember how you doubled that number for me? And then I wrote that, I know I have everything in terms of M1, M2, and M1 and M2. But remember, somewhere in the directions it says that they explode into equal parts. Let's see. There it is. Equal mass. 2 fragments of equal mass. Okay. So, excuse me, please. So I just let all the M's become just a regular M because they're all the same. So here it is. And that's going to work out really nicely, because since all the M's are going to be the same, P.S., remember, you will have a different answer than this. This is going to be, your X1 position is where your mass 1 landed. So whatever you got right here in blue, see my star? Watch my star. Whatever you got right there in blue, that's what goes in here, because that's where your first little mass landed. And then our goal is to figure out where the second mass lands. That's why I didn't fill in for X2. And remember, right here, this red goes in here. And then since these were both M's, this becomes 2M. And now since you have a common factor of M, all your M's cancel, multiply by 2, do some awesome subtraction, and that'll tell you where the second fragment will land.